Let me know once you start. Okay, I can see it. Okay, so for the next 5-10 minutes, we'll just quickly go through the process of reviewing a paper, where the goal is to, yeah, obviously understand and appreciate what the authors have written in the paper. But it's also a process through which you can find new ideas or insight, or you can provide better feedback to the authors or to your friends who are writing papers, right? So it's an exercise that kind of helps developing critical thinking, because you kind of think deep more and more about less and less. Okay, that's what this process is. Uh, so typical review that you will be actually doing through this course is the first thing you should summarize. Okay, and you can easily now correlate summarizing a paper can be just pasting the abstract, right? No, so do it in your own words. Write a small paragraph about what exactly is the paper, what exactly it does, right? In your own words, right? And it should be unbiased. You should not say this is an awesome idea, pretty it will change the history of computer architecture, blah blah blah. Completely unbiased at this moment. Okay, this is step one. This is just a summary. Okay, next you try to find out the contributions of the paper, right? So if I have to correlate with the previous paper, you will say that, okay, they proposed LIP, BIP, and DIP. The nobility was previously, the paper, all the ideas were actually not dividing the replacement policy into sub policy. They were solving as one policy. And this paper has introduced that, right? So this is the contribution. The hardware overhead is low. The performance improvement is good. It's closer to the optimal, right? At the same time, you should have an open mind and try to find out any technical flaws, right? We'll see how to find that out. Um, this is also a phase or a step where you should try to see, are there any difference or are there any gap between the abstract and conclusion? So in the abstract, if they say we propose LIP, but in conclusion they say no, LIP didn't work, right? That means it's a red flag, right? You'll also find, some awesomeness in the paper. Let's say pretty neat idea that improve performance, right? That's the wow factor, right? Again, but having said that, you should keep your eyes open for any technicalities, okay, which are not discussed properly or which are not that conclusive. Then you should actually talk about only the positives, even if the paper is, it has technical flaws, it has so many issues. Every paper you'll be able to find out some ideas, okay, some good things about a paper. Even if the paper is not, let's say it's not worth getting accepted in a top conference, but still it will have something, right? So try to find out the positives of a paper, and then uh, maybe when you try to find out the strength, that time you can actually ask yourself, if you would have solved this problem, what would have been your approach, right? Is the approach incremental, or it's completely new idea, or it's the solution proposed is already proposed long ago, no one is working on this field, right? Anything can happen. So while finding out the positives, keep the negatives also in your mind, but don't write them in the strength part, right? Jump to all the negatives in the weakness section, right? When you're writing a review, have a paragraph or have multiple points within a paragraph saying these are the weaknesses, right? This paper doesn't talk about what happens on a multi-core. This paper doesn't talk about what happens on a large cache. You know, someone talked about bandwidth. What happens to bandwidth? They didn't talk about it. Blah 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 blah. Right. Having said that, weakness doesn't mean that the paper is bad. Okay, every paper will have weakness. It's not like the paper that gets through will have zero weakness points. No, that won't happen. So finding out weakness is actually a good thing. It may help you finding out new ideas, or it may help authors to come up with better ideas. Right. So finally, this is the complete flow. When you are reviewing a paper, first try to get the why and what factor before jumping into how. So how is the implementation detail, right? For example, in this paper, the author says something like set dwelling. Set dwelling is not important to start with. The first thing to jump into this paper is there is a problem with the LRU policy. Why you should solve it? Because 60% of the blocks are not getting any hits, right? Then you jump to how, right? So that's why the first step is only about why, right? What will be the ideal solution? The ideal solution is OPT. The paper says that, okay, we are closer to OPT, so which is a good thing. That means the gap is actually now they are successful in bridging the gap, right? Then you come to the how part and look at, okay, how good is the solution? Is it practical? Can industry adopt it straight away, or there are issues, right? Whether hardware overhead is high, or there are other attributes that are affecting, maybe security, because it's a course on both performance and security. You propose a new replacement policy, but will it leak more information because of dynamism? We don't know, right? So that's the overall process. This is what I do. I have been doing. I still do it even today when I read a paper. You know, follow old style reading, right? Have a notebook, or maybe in today's world have an iPad or whatever. And then while reading, you mark your sentences, note them, circle them, and then come back after you finish reviewing and see whether those points are kind of clear now, right? If not, maybe you are right, and then there are so many things that are not clear in the paper. The paper is not written well. They haven't just justified everything that they were talking about, right? So that's all. That's the entire process. A few more points which are actually kind of obvious. So if you don't know about some basics, let's say you don't know anything about caching, so obviously you have to learn caching, right? And similarly, like even if you don't like a paper, you should not, blast that paper. The first and foremost thing that you have to learn is how to become professional, right? But at the same time, you should write, critical points and provide constructive feedback, which will help the authors or which will help your friends. So, right. This is pretty common that I have seen among students, right? When they submit reviews. This section is not good. That plot is not good. This is not bad, blah, 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 right? That won't work. You have to defend every statement that you make in your review. If you say this plot is not good, defend why, right? There might be some typos, some grammar issues. That's okay. You can say that, okay, some minor comments here and there. But that's not my major concern. My major concerns are I have already talked about in the weakness section, right? This is again a tricky point. The third point, you will find some of the papers are really written well. Okay, they're well written papers, right? And it may happen that you'll be in awe, right? When you read those papers, you'll say, oh, there are no negatives in this paper. This is just the best paper that I've ever read, right? Be careful. You won't find a paper where you won't be able to find mistakes. Okay, so well-written papers are good, but they should not put anything, under the carpet. So be careful with that. Okay, so with that, I will stop. We can take few quick questions before we actually review it. Any questions? I'll actually stop sharing. I will actually go for the mock. Are you guys there? I can't sense anything.
Yes, sir. So, like you
Yes, sir.
told that you are reading a paper, and if you, let's say, words you get like when you're reading caching. Let's say I am new to computer architecture. I didn't know what uh, insert LRU policies. Let's say I don't know. So what should I mean? I should quickly stop reading the paper and jump to what LRU policy is.
Exactly, exactly, exactly,
Read it
exactly.
again, then come back to the paper.
Yes,
Or
exactly.
just go through a paper, read all the points you don't know, and then go back. Like, what should this approach be? Like
Okay, so
sometimes I get, I mean,
I got it. I got it. I got you. Okay. So the question is, if you don't know something that is mentioned in the paper, what's the approach? Should you jump out and then come back straight away, or you continue reading it and then mark it and then come back later after reading those marked points, right? So it
yes, sir,
depends.
exactly.
It depends on the intensity, right? This paper is all about replacement policy. If you don't know LRUs, then there is no point reading the LRU paper. Having said that, there might be some concept. Let's say there is another paper that says, okay, we use set dueling, and they have just cited the paper. They didn't explain anything. right? In that case, maybe you may go to the paper first and then come back and read set dwelling and read the paper again, connecting the dots. Does that make sense?
Yeah, so I mean that the wordings which are really core to the subject, we could study them, but which are like cited, like this is better than that part, or this is better than that particular policy, so that we can read that policy later.
Yeah,
First, we should go through the paper.
exactly.
Okay,
So
thank you.
that's why it's called background and related work. Background is like a textbook material. CAS is organized
Okay.
as a associative CAS. There is a replacement policy. So this is background. Any student who has taken a undergraduate architecture course, he or she will know about it, right?
Yes.
But the moment they say, oh, no, 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 some applications have thrashing access patterns. OK, the textbook doesn't say that, right? So if you don't know thrashing, you don't know there are some applications that can thrash, then maybe go back and read papers which are also talking about how applications can thrash the CAS, right?
Okay, thanks.
Okay.
So you said that we don't propose a solution after reading this paper, but in this review you said that we first point out the flaws, then later on
We
think that
may.
do the solution.
We may. So the solution part here is a bit tricky. It's like what if, right? So when someone says, OK, I solved this problem this way, but as a reviewer, you can say, what if you do that way? Right? Having said that, the paper is not about your way. You are reviewing the author's way of doing things. OK. So you should not, start reviewing with your idea as the best idea in mind, saying, OK, anyway, my idea is the best and the author's idea is actually below par, right? No, that's not the right way. You can suggest in the review saying that, could you try seeing what happens if you do this, right?
So in that way, we cannot compare the different implementations. We can just comment that there is another way. So
Yeah, so let me tell you the entire process of review, at least in conferences, the reviewer will say, OK, I'm not pretty sure about this plot or this performance. Can you do these experiments and then, come back after 10 days? So the authors will actually, implement, experiment, and then put a new plot saying that, OK, yeah, you are asking for this plot. Now here is the plot. Right? So that's how it works. But most of the time it happens that the concerns are so many that within 10 days you can't, address all the issues. The paper will be rejected. You will submit again maybe after 2-3 months after addressing all the concerns. Okay, so that's the process. It's an iterative process which continues. Any other questions?
So, sir, as a part of this course, in this review, we means what procedure mean we cannot actually replicate this procedure, means ask the author to.
No. Here your authors are your friends, right?
So we can ask them to reproduce results.
No. We can't. Otherwise they will drop the course. Here you can just suggest, right? That's all. And then it's my job to check whether your suggestion is good enough. That's where I will jump in.
Sir, in review, do we have to explain the methodology used by the
No. That's the paper itself, right? Why to explain again? Right?
Yeah.
You have to review the paper. You should not rewrite the paper or rephrase the paper. Okay. Maybe for next 5 minutes, can you just open this paper on your laptop and then just go through the figures, plots, or maybe anything that you want to look, right? I'm assuming you are on laptop and you are not connected through your mobile. Even if you are connected through mobile, it's OK. You can just go through it, download it, and then start seeing it. We started with the expectations, right? So as a reviewer, after reading the abstract, you had so many expectations. Just see whether they were fulfilled.
Sir.
Yeah.
Sir, it's a very, I don't know, good question or not, but
It's okay.
what,
Just shoot.
okay, so what do you think, how much the conference and the author matters?
The conference matters, obviously. Authors you won't be able to know, right? Because you are reviewing in a double blind process. At least even for this course, it will be double blind. You won't be knowing like who is your friend, unless your friend has actually shared the PDF through WhatsApp group. Because it's a small community, this course, right?
Yeah, okay. So for example, in this paper, there is this Professor Yale Pat. So
Yeah,
I
but
just
while
knew him.
reviewing, you don't know, right? Whether the author is Yale part. While reviewing, this part will be completely blank. It will be white space.
Uh, okay.
That's why it's double blind review. You don't know who are the authors. The authors don't know who are the reviewers.
Okay. Okay.
Yeah. Otherwise, there will be papers only from MIT, right? IIT Bombay guys will be they will struggle. Okay. Anyone, any comments? Anything that you want to share? By the way, any feedback so far? Will this work? Whatever we are doing, is it helpful or it's too much or no comments?
It's good, sir.
Okay, cool. So at least there will be one student. So we'll continue. Okay, so let me go through it and let me just show you how I review papers. Okay, so for example, even I'm reviewing ISCA papers this year, right? So we have already read abstract. So what I will do is I will do this thing. Can you see it?
Yes, sir.
So these are my, key points. I don't care about the rest of the abstract. So for rest of the paper, I will search for LIP, BIP, and the idea dynamism. That's why the title. And there is some performance numbers. I would like to get detailed, explanation. Then this statement. Okay. So this will be my checklist kind of for the rest of the paper. Okay. Once I have that, assuming I know the basic paragraph about replacement policy, I'll just leave it. Then I will go for the introduction. I find something is written in italics, right? The font is different. So whenever you find something which is, the font is different, that means the authors want to emphasize something. So in LaTeX, it must be written in /EMPH, right? So these are the points that I should look for. For example, here, right? Here. And there is a percentage here, right? So this entire introduction is full of we show, we propose, blah, 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 right? So yeah, I will just create a, image of the entire proposal. And finally, I will just see, I will kind of connect whether this 21% was mentioned in the abstract. There is this OPT. What about evaluation? It's evaluated on 1 MB, whether it's good enough, right? Having said that, there is something new, which is set dwelling. Again, it is a different font, right? So let's read this. It says the set dwelling mechanism dedicates few sets of the cache to each of the two competing policies. So the competing policies are LIP and BIP. Okay. And and it uses the policy that performs better on the dedicated sets for the remaining follower sets. So these are all new terms, dedicated sets and follower sets. OK. So if I try to understand this particular mechanism, it says if I have a cache, so let's say this is my cache. And these are my sets. Let's say set 0 to set k. OK. This proposal is saying that there are few dedicated sets. Let's say the first two sets are dedicated sets where a particular policy will be used. That means there will be a cache set where LIP will be implemented. And there will be a cache set where BIP will be implemented just to see which one is doing good, right? And then for rest of the sets, assuming your cache has 1000 sets, if you do this experiment, let's say on 32 sets, which are known as the dedicated sets, then the rest of the sets are known as follower sets. And the follower sets, they use LIP or BIP depending on who wins this, right? And then the winning policy is the policy that provides better hit rate or better, reduction in miss rate, right? So that means this is something new, and they are saying that they propose because it starts with we propose, right? So definitely you would spend more time here because it's a new technique that tries to solve this problem, deciding how to provide adaptiveness, right? OK. And motivation we have already discussed. So you have to just make sure that what are this x-axis and y-axis. So in computer architecture and systems, you will find a term called benchmark. So benchmarks are nothing but some applications which are widely used. And any paper that you review, you will find they must have used some benchmarks. OK. So these are like standard benchmarks. Any architecture paper, if they are proposing some new idea, they have to go through these benchmarks. OK, so that the entire world can actually compare against each other. So here they are saying 60%. OK, cool, good enough, no issue. I'm OK with the motivation. Then let's say if you are not aware of what are the benchmarks, they have given more details. So this is actually a background material, this experimental methodology. So after reading your first paper for this course, you will start ignoring these sections. OK. And these are the details about the benchmarks. So there is a benchmark name followed by MPKI, which is misses per kilo instruction. More the misses meaning the application is thrashing. OK. So anyway, so let's look into static insertion policy, which is nothing but just doing LIP, right? And then just doing BIP. So they will actually show what happens, right? So this section 4.2 says if you are going for a thrashing workload, so there is a benchmark which is actually thrashing, what exactly happens? So let's see. So if you look at this particular plot, right, this one, it's a thrashing working set. Why? Because the x-axis has the cache size, it's going from 1 MB to 8 MB, and the cache size that is used for this evaluation or experiment, it's 1 MB. That means you are actually here, right? So the misses for kilo instruction or 1000 instructions is really high. And it's going down slowly, and it's almost becoming 0 once you become 8 MB or once you provide 8 MB, right? Which means the cache size is not good enough for this particular work. LRU friendly workload, cache size is 1 MB and the miss rate is constant after 1 MB, right? Which means that there is no need for better adaptive insertion policy for this workload, right? Because it's LRU friendly. The cache size is good enough for the application. So that means for this particular benchmark, if you go for traditional LRU policy, it will do good. But for this particular benchmark, if you go for traditional LRU policy, it will actually make it worse, right? So definitely you would like to see what happens with their policy, the dynamic insertion policy, right? So now you are entering into the idea of dynamic insertion policy and how exactly they implemented it, right? So they are saying that they implemented using set dueling. OK, I'll just take extra 5 minutes maybe just for today, right? So the set dwelling, if you look at it at the high level, it says, there are few sets which are using LRU policy. There are few sets which are using BIP policy. LRU meaning LIP. You are inserting the block in LRU, and there is something called a BIP policy. And then based on which policy is doing good in those sets, rest of the sets follow the winner of these two. It's like a multiplexer, right? You are selecting the best policy out of these two policy by running them on few dedicated sets and not on all the sets, because otherwise it will be too costly and it will be impractical, right? So that's why there is a section on dedicated set selection policy, right? So you have to dedicate few sets only for LRU, dedicate few sets only for the BIP, because if you use all the sets for BIP, then the idea will be suboptimal. And if you use all the sets for LRU, again, it will be suboptimal, right? That's why we need adaptiveness. Okay, so this is how you should actually read. But one thing that is kind of which is not that obvious is how to look at these plots. Okay, if you look at figure 11, it says reduction in L2 MPKI, which means reduction in L2 misses. Okay, forget about the technicalities. You should actually have an eye to look at outliers. So I can easily see outliers here. And it is actually going below 0. That means something is wrong with these benchmarks, right? So the moment you see something is not following the average trend, you should search for text defending or explaining this trend. That means in the paper, there should be text which will say that, OK, this is the reason why, let's say with swim, things are not improving, right? So there should be some section which says swim is actually behaving like this. That's why our idea is not improving or something like that, right? So just do a grep on swim or just do a search on swim. There should be some paragraph. If you're not getting it, that means the paper is hiding something. OK. Similarly, you should look at all the other cases, right? One mantra that I would like to provide, if you're reading a paper where all the bars look good, all the benchmarks look awesome, they are providing awesome, then there is something really wrong in that paper. That won't happen. At least I haven't seen in last 12 years. OK. So this is the usual procedure. So you look at the idea, look at the corresponding effect of that idea in terms of performance, and then finally, in all these cases, you try to see whether there is an outlier, whether there are any issues that are not explained, right? And since the authors claim that they need 2 bytes, so that there is some explanation here and there, how to decide which set to use and blah blah blah, right? So that's how it is. You'll actually review with this particular with this mindset. But I think maybe in the interest of time, I'm not showing other details. What you should do is you should, when you are reading the result section, you should actually go back to intro again, right? Sometimes you may find that some things are not straightforward. Let's say, for example, in swim, we didn't get better performance, right? We should come back and see what happened with swim. OK, with swim, around 50% of the blocks are, they are not reused, but still there is no performance. What's happening, right? Let's say for this one, if you're not getting performance, you can assume that, OK, for this benchmark, only 10% of the blocks were actually not getting reused with LRU. That means there is no scope for future improvement, right? So these are the things that you should try and then connect, different sections and then see whether they are actually doing what they are claiming, and based on that, come up with your, strengths and weakness. OK, so I'll stop it here. Otherwise, it will be too much. It will be overwhelming even for me, right? If I just keep on talking like this. Do you want another session on Monday on this, or it's good enough? I'm OK either way.
Sir, can you share the template for the LaTeX?
Yeah, those things we will do. Logistics we will take care. Don't worry about that. I'm talking about the process. We spent around
So
90 minutes. Yeah.
Sir, if you can, then one more session may be good.
On reviewing,
sir.
is it?
Yes, sir.
Yes, sir.
Okay, maybe on Monday for first half an hour or maybe 20 minutes, we'll go through this paper again, but with more questions because we haven't asked questions now, right? I kind of rushed through it. We can do that, and then I'll jump to something else. Is that okay?
Sure. Yes.
Any other comments or suggestions?
So, sir, what will we be covering next on Monday then?
Yeah, so my plan is this. Let me know if it makes sense. I was thinking I will jump into CAS attacks. Assuming you have already gone through videos and slides on basics on CAS. I'll just provide a 10,000 feet view on CAS attacks on Monday. And Thursday, I will spend 1.5 hours explaining all the projects that are possible. Because I saw some of the comments on the Google form saying it may be, it will be too much for the students to come up with ideas. So I will just provide, high level ideas, high level issues that which are kind of concern, at least from industry point of view and research lab point of view. And I think from 17th onwards, we will just start discussing, new topics. So next week, I'll just give an overview about attacks because that's something new. Performance, I'm assuming more or less, misses, latency here and there. But again, I'll give you more details on next Thursday, right? So next Thursday, we'll have two sub-sessions. One will be, project topics on security, project topics on performance, right? So that's how we'll do it. Monday, I will talk about the basic of security, and then we'll provide some source code that you can play with and see how you can mount attack on your laptop. Okay, is that good enough? If not, then let me know. Because finally, it's up to you. Maybe a thumbs up from everyone will be good. I will get an idea.
Professor, it would be really useful if you can share some articles regarding attacks also, like you had shared some PDFs on basics of cache.
Yeah. So once I teach or once we start discussing the CAS attacks, I will share. Okay, I will share slides. I will share videos. Those things are there. I will do that.
Okay, sir. Thank you.
Yep. So what was this exercise useful? Whatever we did today?
Yes, sir.
Yes, sir.
Yes, sir. It was good.
Okay, cool then.
Sir, I have a doubt here. So like while reviewing, like in this paper, set dueling is a topic that they introduced. Do we have to verify these claims?
It's not a topic. It's just a new implementation technique, right? You have to verify, meaning, okay, so there is something in the appendix. So if you go for, at the end, there is this appendix. Okay, I usually, so this is one of the, outlier paper where you will find equations in architecture paper. Usually you won't find equations. Okay, it's not a theory paper, but this paper has some claim, analytical claim along with the empirical claim that this is good enough. Okay, so either you have to look at the empirical analysis, or if you are not satisfied with that, you have to go for this one.
Okay, sir.
But mostly in 99.99% of the papers, you will find that there won't be any analytical modeling, or there won't be any equations that kind of defend their claim. It's completely empirical.
Okay.
Okay. I think there must be some other course slots now, right? It's 5 o'clock. So let's wrap up, and we will actually. So Devasi's, just make sure to share some forms about class timing and other things. Okay.
Okay, sir.
Sir, I have one more question.
Sure.
So, will we be having mocks of paper presentation also?
Yes, exactly. Why not? You will have it. Before we assign the papers, I will have one session on paper presentation.
Okay.
Don't worry about it. Yeah. Because these are the three pillars, right? Reading, reviewing, and presenting, of course, along with the project, right? So I'll spend time. I'll spend enough time explaining all these processes. Okay. Okay then. So all good. So there is a deadline, by the way, on 10th. Devasis, am I right?
Yes.
Yeah. So you have to go through one of the movies that I have floated and then submit your 250-word review, right? So if you don't like watching movie, it's a punishment. You can take it that way. Yeah, Devashish, I guess you can stop recording and we can wrap.